תודה רבה לאוהד הצופה, אכן עשייה רבה ועוד היד נטויה. המרצה הבא, אני מתכבד, זה פרופסור רפאל ארלטז, ראש המחלקה לשימור המגוון הביולוגי באוניבריסטת ברן בשוויץ. המחקר של פרופסור ארלטז עוסק בשימור טבע ובשיקום מינים בסיכון. עיקר המחקר עוסק במינים בסיכון של חסרי חוליות וחולייתנים, בעיקר עופות ועטלפים. פרופסור ארלטז מוביל את המחקר וניטור של אוכלוסיית הפרסים המושבים לאלפים השוויצריים. זה כבוד גדול עבורנו, פרופסור ארלטז, שוויתר בעבורנו על חופשת חג המולד עם משפחתו בשוויץ כדי להרצות ביום העיון הזה. נושא ההרצאה השבת הפרסים לאלפים, סיפור הצלחה. Welcome.
First of all, I'd like to thank the organizers, especially Yossi Leshem, for inviting me to present some stuff. It will be in English, as you can guess, and not in Hebrew. I have to apologize for that. Last time I was in Israel, it was to talk about vultures already, and this was 5 years ago, and I was invited by Ohad, who just spoke. So I'm very much impressed by the crowd, and I think this is what in Israel you probably call the Yossi Leshem effect, not? So today I'd like to talk about these guys. These are really fantastic birds, the bearded vultures, one of the most beautiful birds we have on Earth, and from their behavior point of view as well, they are very fascinating. I don't know what is saying this guy because he was talking in Hebrew and then it vanished. So the bearded vulture is a fascinating bird, and you know that I visited Israel in the 1980s, and I saw one of my first bearded vulture in Israel. This was in En-Gedi, and a few years afterwards the species vanished, unfortunately. And now there is a scope with the growing population in the Alps and all the know-how that has been gathered in our reintroduction project, maybe to envision to have these birds back to Israel and to the Middle East one day. So these birds, they are really fascinating because they have a diet which is specialized on bones, which is quite strange. To have a diet specialized on bones sounds quite weird, but in the end, you have to know that the marrow, which is inside the large bones, is much richer in lipids and in proteins than the flesh, than the muscle itself. I don't know why they are playing some Hebrew, and I don't understand what's going on, but you apologize me for that. So if we look at the bearded vulture, what is quite fascinating is that they are always the last bird to arrive to a carcass, and they really wait until all the flesh is gone, and then they are doing their job. And this is very well depicted with these pigs that I'm showing here. You have here a dead fox that with a friend we found dead on the road, and we attach it to a rock. We put a hide to take pictures, and you had, first of all the scavengers like the ravens, the golden eagle coming, and then a few days later, when all the flesh was gone, the bearded vultures arrived and they started to take the flesh out of the carcass. So they have really this specialization on bones. The very large bones, they can be swallowed. And this is quite impressive if you see a bearded vulture kind of swallowing one of these very large bones. And in this X-ray picture, you see the bone here, which is inside the body of the bird, which has just been swallowed. And for digesting these bones, they need really to have a very acidic environment. And the pH in the digestive tract of a bearded vulture is roughly 1, which means it can even digest these mineral elements which are making the bones. If the bones are too big, what do? They just carry them to the sky, and then they drop them on slabs of rocks, on screes. They break the bones in small pieces, they go down to the ground, and they pick up the marrow and the small pieces of bones. So here you have the behavior displayed in these very nice pics. A very good technique. If we look at the ecology of the bearded vultures, they are very much linked to the ungulates, to the wild ungulates beforehand. If you are in Africa, they will eat a lot of carcasses of antelopes, gazelles. If you go to the Alps, it's the big, large ungulates we have, like the chamois, the ibex, which is a cousin of the ibex that you have in the south of Israel. And there is, of course, a strong relationship with the top carnivorous predators. You know that we have the lynx and the wolves arriving or recolonizing Europe, and these big predators, they do a lot of kills, of course, they kill a lot of animals, and then the carcasses are available for the scavengers, what remains from the flesh, for the vultures, and in particular the bones for the bearded vultures. The domestic ungulates, they play a minor role in the diet, especially in the Alps. Why? Because they are not available during the summer season, during the winter season, sorry, they are in the stables in the low elevation places in winter. So the bearded vulture was exterminated from the Alps in the 19th century, and it has been reintroduced from the year 1986 when the first bird was released in Austria. So why was the bearded vulture exterminated? There are several reasons explaining that. First of all the wild ungulates, they had been, or most of them, they had been extirpated from the European Alps during the 19th century. At the end of this 19th century, there was almost no roe deer, no red deer, very few chamois, no ibex remaining in the Alps. It meant less food supply for this guy, and this guy, they still wanted to make a life, so they approached the human settlements, and they were looking for the carcasses of the domestic ungulates. And this was a dangerous time, because bearded vultures, they are very curious, and they approach humans to observe what's going on, and when they were looking for these carcasses of domestic ungulates, of course, they were very easily shot by the people who hate them and confused them with other big predators which were damaging the livestock. So this is one of the main issues which caused probably the extirpation of the species from the Alps. And then, of course, there was the problem of the poisoning. And we might believe this is a very old problem, but I guess that we have to face the reality that poisoning is still something which is going on and damaging our ecosystems. Poisoning was not against the vultures, of course, it was against the wolves, the lynx, and the large predators, but as a cascading effect, it generated lots of problems to all the scavengers, including the bearded vulture. The last pairs of the bearded vultures, they bred in the Alps around 80, 90, we are not so sure, but very soon the population was exterminated, and the last individual was shot in northwestern Italy in the Aosta Valley in the year 1913. And with that, the species was considered as being extinct from the Alpine range. Of course, there is a lot of mythology going on. Here you have a picture of two bearded vultures attacking. I think it's probably one of these first British tourists coming to the Swiss Alps. And you have another guy sitting there. And what was well understood from the archaeology at the time is that they were really linked to the bones because you see a carcass. And this is the corpse or the skeleton of humans, if you look into the details. So people thought these guys, they were dangerous to humans and killing humans. They understood that they were feeding on bones, but they didn't make the proper ecological link, of course. I realized last night that this bird depicted here is exactly the same as in that pictures, meaning that there were very few pictures probably circulating, and people copied and copied over the same stories during decades. So this bearded vulture here, very romantic view, who is now kind of approaching the carcass of a sheep that people probably at the time thought had been killed by itself. And we know that they are only scavenger now. So lots of stories with bearded vultures here depicted with a goat, bearded vulture carrying a lamb in the air, which is absolutely impossible because if you look at the claws of a bearded vulture, it's like in a hen. So they could never carry any kind of big prey in that manner. Looking at the distribution range of the bearded vulture, historical range, you see that the species was occurring and still occurs in many areas of the world, but it's especially in the Western Palearctic that the population has diminished dramatically, with the case, of course, of the Near and Middle East here, where the situation is critical, like in many other places. There is evidence for the overkill of the bearded vultures in the late 19th century from the Alps. This is a work by Esteve and Mingozzi, Italian and French colleagues, and they could found in the registers of the local communities number of birds which had been reported killed by the hunters, and it's quite obvious that this is really in the second half of the 19th century that most of the damage to the alpine population was done. So this map shows the situation with a lot of population which have passed away, like all the bearded vultures from the Balkanic Peninsula. The situation in North Africa is not brilliant. Near East and Middle East is not brilliant either. But we still have some native population in Crete, Corsica, and the Pyrenees which remains. And then we started to release birds in the Alps in their historical range. This was done at 4 different places, release sites in 4 different countries: Austria, France, Italy, and finally Switzerland. So what was done is that the birds were reared in captivity, and the young were taken from the parents, and then just before fledging, they were released to an artificial eyrie in a rocky cliff in nature. So the technique used for reintroducing is called the hacking technique, because you kind of not imprint the young. You don't, so to say, put them in contact with humans, and then you try during all the development process in the wild to avoid any contact with human, to avoid what we call human imprinting. So this picture this is bearded vultures on a rucksack backpack, which is taken to an artificial iris. And here you see the cliff. This is a big niche in the cliff. You see a bird sitting on the ledge. And look at this. This is a huge plastic tube used for feeding the guys, meaning you put the bones in the tubes, and then the bones arrive on this platform, and then the young, they feed on the bones by themselves. And this is the way you can avoid contact with humans, so that these guys develop a sort of wild behavior, if you like. Once the birds were started to be released, the question was, how many individual young birds can we release every year to the wild without risking of jeopardizing the captive population? Because there were several zoos in the world having breeding pairs, including, I think, Tel Aviv Zoo for a while, but I think now they have stopped breeding. And then the question for the scientist was, how many individuals can we extract from this captive population without risking to lose too many guys? And a Spanish guy working at the time in Vienna, in Austria, he did what we call a population viability analysis to see how many individuals could be released. And he modeled that, and he said we should not release more than 6 to 8 young a year, otherwise we are going to risk losing the captive stock. And this was a very kind of important investigation which set the stage for the release strategy for decades. So if you look at this value here, it's a bit statistical. I'm sorry for that, but if you would extract 3 males and 3 females, meaning 6 young a year, then the probability of extinction of the captive population would be 1.6%. If you would release 5 males, 5 females, then it would climb to 9% already. So people decided to be on the safe side and to release only 6 individuals a year, and this was done over the years. Of course, this projection is quite old. It's a paper of 1996, but and it is based on 50 males and 39 females, which were by then present in captivity. But still, it sets the stage. Altogether, since then, more than 200 young were released until the year 2016, a bit more than 204 if I well remember. So once the guys were released, of course, what had to be done was to monitor the population. What were the whereabouts of the birds? Were they flying to? And this was important to estimate, of course, whether they could get used to their new environment, the alpine range. So for that, we use observations of the birds, visual observations, and we used as well radio tracking and more recently GPS tracking. The visual observation, they are eased by the fact that during the first years of life, the birds, they have their feather bleached with a peroxide, oxygen peroxide, and here you see the bleached feathers, and this enabled to recognize the birds. So I was in the field very early, already in the late 80s, and started to make pics of these birds, and this is a bird released in southern France that I had observed in the northern Alps. This is another guy released. He was shot, this guy, by a hunter a few years afterwards, unfortunately. But, I mean, there was a good way to kind of track these birds across the Alps. There was a problem, however, and the problem is that the bearded vultures, they had these white markings in the wings, which reminded a bit the natural coloration pattern of the young golden eagle. And there was so much publicity made around the bearded vulture that some people reported in mass observation of bearded vultures, but there were so few bearded vultures that we were a bit confused that there were so many observations, and we realized very soon that people were confusing the young golden eagle with the bearded vulture, meaning that there was a lot of education, outreach activity which had to be performed to educate the people to the bearded vulture. So based on this observation, then we wanted to know where were the birds settling and whether we can learn something from the places that they were visiting in priority. And then based on that, we built what we call habitat suitability model, which we thought would be helpful for deciding where to organize the next releases. Because if you know the ecological links of the species with its environment, it's of course much easier to kind of foresee the next release or reintroduction events. So for that, we looked at the distribution of the observation and linked them to 23 different environmental descriptors. And we noticed that there was a clumping of the observations. And the clumping was a bit confusing. We didn't know, is it an observer effect that we have clumped observation, or is it the fact that the bearded vultures, they prefer some places towards others? And for that, we use golden eagle data, and the golden eagle survey data, they show no, the clumping of the observation reflect the real behavior of the birds, and it's not an artifact due to the observers going to certain places and not to others. So you have here for the southern western Swiss Alps, for instance, a map showing where you have observation of immature birds in, these are the black squares, and adults, these were the white circle. And based on this information, then we built what we call an ecological niche factor analysis to try to understand what were the most important factors of the environment to explain the distribution of the birds. So if we look at the outcome of this investigation for the young bearded vulture, the immature, what is quite striking is that there is a link with the availability of the ibex. The ibex is the main factor explaining the distribution of the young bearded vulture. Then if you move to, and this is a nice picture showing the relationship between the bearded vultures and this ibex. And then if we look at the preference of the adult bearded vultures, it was no longer the availability of the ibex, although the ibex still played a role, it was the presence of a limestone substrate. So the geology started to play a role, and we were thinking for ages what is the relationship behind it, and we found that in the end they need to have screes for breaking the bones, and in limestone areas you have much better screes than in other areas where you have mostly granite or gneiss substrates. So a link between the limestone and the bearded vulture at the adult stage. So if we look at then the distribution of the first nuclei of breeding birds, in this map here you have the release sites and then the nuclei of population which have built over the years. There is a clear link between the substrate, the limestone and dolomite substrate, and the presence of the ibex, and this explains in the Alps why you have clamped a distribution of the first breeding pairs after all these years. Then we were interested in another aspect, and this was the demography of the birds. And for that, we used the birds which were marked and recited. And this is the basic matrix that you observe. You have here the years, and these are all the different individuals, and you have the history of all these individuals, meaning if you have a 1, it means the individual was observed in a year. If you have a gap, it means the individual was not observed, and a cross mean this individual passed away during a given year. And based on a very simple table like this one, we could build a habitat suitability model which integrates what we call the probability of detection. So this sounds very complicated, I'm sorry about that, but these birds, they are very long-lived, and to understand the demography, you have really to have a fine-grained approach. What you recognize here are different age classes, from the juveniles up to birds which are 10 years old, and then this is the entry of the different birds into the reproductive stage. The S values, they indicate the survival of the birds, and then you have the contribution of these birds to the first class, which are the young. And if we look at this data and analyze, you can calculate what we call the survival rate. And the survival rate was really fantastic. Among the young, the first-year individual, we had a survival rate of 89%, and if we look at the adults, we have 96% survival rate. This was really not expected, meaning that these guys, they are really long-lived, and in the Alps, they find conditions which enable them to survive very well. A bit more of statistic. Here, we did some modeling for knowing what would be the fate of the population if we would continue to release. We did this study in 2006, and this is another period of 5, 10, or 25 years with a continuation of the releases with 6 young a year. And what you see from that, and you have different scenarios considering the fecundities being constant or being due to random factors, with different fecundity level from 40% to 100%, and roughly now we are at 66% around these square values, if you like. And this is the population growth rate as it could be predicted by the model. So basically a stable population would have a lambda value of 1, meaning along this line. And as you can see, all these projections here, they show that we have, in 2016, given that the releases have continue for 10 years after we did the study, we are on the safe zone, meaning that there is a very low risk of losing the population of the bearded vultures in the current environmental conditions. But if the conditions they start to change, then we might have a problem, and the problem that we foresee for the future are double. First of all, we have the spread of the wind turbines, like in every part of the world, at least in the Western world. And then we have this problem which is emerging again. This is poisoning against the big carnivorous predators, especially the wolf. So what does it mean in terms of demography if you would have new impacts, new sources of mortality caused by this new technology, a spread of infrastructure, or new method to fight against the predators? If we assume we had a population with 200 bearded vultures in the Alps, such a population would lose every year, under the current circumstances, 8 individuals, which corresponds to this 96% survival. Meaning that the population, if there is an increase of mortality, would at a point start to face some trouble. So you have here again the population growth rate with this lambda value which is set at 1. And as you can see here, the scenarios say that if we have an increase in the mortality risk, which is greater than 50%, meaning that instead of losing 8 individuals under current conditions, we would lose 13 individuals instead, meaning that if the wind turbines or the poison would kill just 5 adult bearded vultures a year, then we would enter a zone which is very critical. And the critical zone is the spread of this wind turbine on one hand, and then this poisoning against the returning wolves. So we have to keep an eye on that, and now we are launching a problem for trying to understand the behavior of the birds. In addition to the bearded vultures, we are going to work as well with the golden eagle to see where we can mitigate these problems. But so far, the population of the Alps is quite well developing. It's an exponential increase, exactly like you would expect. You see here the number of fledglings which have been produced over the year, and these are the number of successful territorial pairs. Up to now, 173 young were born in the wild, in addition to the young which have been released to the wild. So if we look at the situation of the bearded vulture, there are reintroduction projects which are envisioned in these parts of Western Europe, but we have still critical situation in Northern Africa, in the Middle East, and in the Balkanic Peninsula, and at a point it would be good to see whether we can improve the status of the species across the historical range. So basically, if we look at the situation, we have only 3 main native populations of Europe: Pyrenees, Corsica, and Crete. There is as well a subpopulation which is native in North Africa. The population in the Alps stems mostly from Asian birds, because birds were captured in Asia and released there. And finally, you see that I've put here the Israel cross with maybe another place where something could be done. So reconnect the Alps with the Pyrenees. This is the first goal that we are going to we are achieving now. This is almost down now, and it suffices to have 1 individual crossing between the Pyrenees in the Alps every generation for having enough genetic admixture, if you like. Then we have a strategy to kind of put the feeding places in the Pyrenees at the border of the range to increase the spread of the population. Now the species is reintroduced in southern Spain. There was a first successful breeding this year, and then there will be a link with the Pyrenees. Then we expect to have the link with the North African population, which is in real need of support. There is the problem of the Balkans, where things should be tackled, and we should really do something for the Balkan. And finally, I think in the Near and Middle East, there is something which should be done. And of course, here the big question point, as we have heard before, is the poisoning and maybe other threats which might emerge. So basically, I would say the know-how transfer has already started. We had the visit of Yossi family on Ehud Biedermann visiting Switzerland last summer, and we discussed a lot about the possibilities for the future to do something for these birds in this part of the world. And with that, I would like to say you Toda Rabba, Ev Yom Tov. Thank you very much.